So far we have seen and discussed various techniques for finding the first occurrence and last occurrence of an element in an array of sorted values, right? So in this video, let's quickly write the binary search based implementation of the same thing. So here I have created the file ready and I have also kept the class also ready. Now all I want to do is inside this class, whatever we have created, let me just define a public function. In the end, the function will basically return the two values, right? One is the first occurrence and the second one is the last occurrence. So ultimately the return type will be integer array containing two values. And let me just name the function name as first and last occurrence in array using binary search. Okay, this function will basically take the integer array of values. Remember that whatever the array of values that we are getting, right, they are already sorted in the ascending order. If at all the array that you have got is sorted in the descending order, whatever the approach that we are discussing, you need to apply the opposite of that so that you will get the implementation for the same thing as well. So ultimately here the array that we have got is sorted in the ascending order. Along with that, we need to take the target value from the user as well. So this target value, whatever that user has passed, we need to return the first and last occurrence of this target value from the integer array. Now, once again, so whatever the algorithms that we have discussed previously for solving this problem, I will write the binary search based implementation as part of this one right now. If at all, if you want various other approaches for solving this problem, you can go out to codingpal.org using the link that is there in the description box, and you will find the remaining implementations as well. So here let's just quickly write the binary search based implementation for the same thing. So here first of all, let me just read the length of the array that we have got. So first array dot length. Okay, if at all the length of the array is 0, that means that array is empty. So in an empty array, obviously we will not be able to search anything, right? That's the reason why we will immediately return a array containing -1 and -1, because there are no values inside the array itself, right? That's the reason why we need to return an integer array containing two values which are -1 and -1. First -1 represents there is no first element. Obviously, since there is no first element, obviously the second element will also be at -1 index only. If this is not the case, now we need to write the important logic for covering all the scenarios. So here, to solve this problem using the binary searching approach, so what I will do is I will define couple of variables. They are basically start and end. End is nothing but the last element's index, which is nothing but length of the array -1. Along with that, using the binary searching, what we will do, we will basically calculate the middle, right? So for that, I'm going to define one variable called middle, and I'm going to initialize it with -1. Now, along with this, I'm going to define one variable called first occurrence index. Okay, so this variable will basically hold the index of the element at which the value is first appearing in the array. So this is where that value resides. Now ultimately what I will do is I will simply run a loop as long as start is less than or equal to end. In this loop, what we will do, immediately we will calculate the middle. That middle is nothing but start plus end divided by 2. Once we have the mid, immediately what we will do, if the value at this middle index is equal to the target value that we have given or not, we will compare that. So array of mid is equal to array of, the target value that we have got. If at all they are matching, that means whatever the mid that we have got, it could be the first occurrence of that value. That's the reason why here what we will do is first occurrence index is equal to, we will simply update it with mid. Now so far that could be the first occurrence, but since there are some other values left side of the mid, there could be a chance that this value could be available before that also. If at all if such case is there, we need to find the further first occurrence index, right? For that, what we will do is whatever the end that we have, we will simply update it with mid minus 1, such that it will go ahead and search the left part of the array from start to end. Now if this is not the case, that means the value at the middle is not matching with the value that user has passed. The other cases could be greater or smaller. Now let's try to handle the case if the value that have at the middle is greater than the value we have at the target. So we have the middle value. This value is greater than the target value that user has passed. That means it could be available on the left part of the array. For that, again, what we will do, we will simply update the end with mid minus 1. And the third case is obviously the smaller scenario. That means array of mid is smaller than target. In that case, the value could be available on the right side, right? That means that first occurrence could be on the right side. For that, what we will do is we will simply update the start with mid plus 1. Now as long as there are some unchecked indexes, it will go ahead and execute this logic. If at all the value at the middle is matching with that specific index, it will simply update the first occurrence index, and it still continues the logic till we exhaust this start is less than or equal to end condition. Once we are done with this loop, we have the first occurrence index in this variable. Okay, in the end we can use this while returning. Similarly, to find the last index, what we will do is we will run the same loop once again, but with fresh set of values. So I will simply be resetting start with 0 and end with last index, which is nothing but length minus 1, and mid also I am going to initialize it with minus 1. Now to hold the last occurrence index, what I will do is I will define another variable called last occurrence index, and this will be holding minus 1 right now. Now all we do is simply run a loop as long as start is less than or equal to end. If at all, if you just want to copy paste the above while loop and make the necessary change, that also you can do, but it's just that let's write the logic so that we will be injecting the code into our muscle memory. So to calculate the middle, what we will do, start plus end divided by 2. Once we calculate the middle, again what we will do, if the value we have at the middle is equal to the target value that we have got. If it is the case, that means the value at the middle is matching with the value of the target that user has passed. That means it could be the last occurrence, right? So to hold the last occurrence index, what we will do is we will simply update the last occurrence index with whatever the middle we have. Okay, now remember that this could be the last occurrence, but since there are some other values on the right side, there could be a possibility that the last occurrence could be anywhere on the right. So to compare all the right side values, what we will do is we will simply update the start with middle plus 1. Okay, remember that if in the case of first occurrence, the value could be on the left side, right? The first value. That's the reason why we have updated the end with middle minus 1. But here the last occurrence could be anywhere on the right side. That's the reason why we need to continue the search on the right part. So the start I am updating it with middle plus 1. If this is not the case, the other two scenarios are, if at all the value we have at the middle index, if it is greater than target, and obviously the last scenario is obviously less than. Now if at all the value at the middle is greater than target, that means middle we have greater value than whatever the target that user has passed. That means the last occurrence could be available on the left part of the array. To search that left part of the array, what we will do is we will simply update the end with mid minus 1. Otherwise what we will do, we will simply update the start equal to mid plus 1. Okay, so that is what we will do. So by the time we complete this loop, whatever the last occurrence of the target value that user has passed, it will be there inside this variable. Now all we need to do is, here we will simply return a new integer array containing first element, first occurrence index and last occurrence index. Okay, so that is what we will do. Very simple implementation. We just need to apply the binary searching 2 times here. Okay, so that's the reason why for finding the first occurrence I have applied the binary searching algorithm once, and for finding the last occurrence I have applied the binary searching algorithm once again. Okay, now let's just try to call this function and see if it is actually working, honoring all the scenarios. So here let me just define an array, and let's just say the values that we have are 1 2 3 4 comma 4 comma 5. Okay, along with that, to call this first and last occurrence in an array using binary search, let's just need we need the object reference, right? So here let me just create the object reference. I can create the static methods, but why? We are used to this one, right? So let's go ahead with the same thing, and let's call the same function array, and here let's just say I want to find the first and last occurrence of the value 4, and let's just store this result we are getting from the function in a result variable, and here let's just print out system.out.println of result of 0, and let's just print result of 1. Okay, since we are getting array of 2 values only, this should be good enough. So if I run this right now, the value of 4 first appearing at index 3 and last it is appearing at index 4. So ideally the output should be 3 and 4. So if I run this right now, run as Java application, see the output that we have got is 3 and 4. Let's just say, let's update this 5 to 4 once again, and 4 is available at the last occurrence is available at index 5, right? So if I run this right now, that is what we should get, 3 comma 5. First is appearing at index 3 and last is appearing at index 4. Similarly, let's just say we want to search for some non-repeated value. Let's just say I want to search for the value 1. 1 is first appearing at index 0 and the last appearing at also index 0 only. So if I run this right now, 0 comma 0 is what we should get. Okay, similarly let's just say I want to search for minus 1, which is not there in the array itself. So in that case what we should get? We should get minus 1 and minus 1. So if I run this right now, see minus 1 and minus 1 we have got. Okay, so similarly, you can pass various other test cases, like let's just say I want to pass array containing only one value and the value itself is something that I want to search. So if I pass this right now, see index 0 index 0, like that, you can pass any other test case and validate accordingly. Okay, if at all if you just pass an empty array, obviously in that case also we should get minus 1 and minus 1 only. Okay, so whatever the implementation that we have done is working absolutely fine. If at all if you want to see couple of other test cases and evaluate your program against those test cases, you can check out codingpal.org specific to this problem, and you will find many other test cases there as well. Okay, like I mentioned earlier, you can find various other approaches, Java solutions there on the problem as well on codingpal.org. You can check out them and give them a shot too. Okay, so that's it for this finding the first and last occurrence of an element in a sorted array. I'll see you in the next one.